What happens if you connect an LED directly to a 9-volt battery? And how does adding a resistor change everything? Let's see. Without any resistor, the LED is exposed to the full battery voltage. The current depends only on the LED's internal characteristics, usually much higher than it's designed to handle, and that's why it burns out almost instantly. Now, let's add a resistor in series with the LED. This time, the LED glows normally, just like it should. The moment we do that, Ohm's law takes over. The current is now set by the total resistance of the circuit. According to the voltage divider rule, the supply voltage splits between the resistor and the LED. The LED gets its safe forward voltage, typically around 2 volts, and the resistor drops the rest. So adding a resistor doesn't slow down current after it. It sets the current for the entire loop and divides voltage to protect the LED. That's the real job of a resistor in series. Pretty cool, right? If you like this breakdown, give it a thumbs up and subscribe so you don't miss upcoming animations like this.